Now another tool that's imperative that you know about for your survival as a Linux or Unix administrator is sed. It's a stream editor. Let's label this section sed, or stream editor. The purpose of a stream editor, or the function of a stream editor, is to allow you to be able to edit streams of text. So facilitates automated text editing. So think of sed as a program that allows you to perform a series of edits to text files, no differently than you would using perhaps Notepad or WordPad in Windows, or gedit or Nano or Emacs in Unix or Linux. It facilitates automated text editing. Like awk and grep, it supports regexes. Basic, of course, POSIX regexes, but enough for you to perform most of the data manipulation that you need. So, what's a typical usage like with sed? Of course, it's available on the system. If you just navigate to a shell at any time and execute which SCD, you'll find it. It's always available on Linux-based systems, and it has some general usage options. For example, sed followed by options, and these are optional options, of course, followed by one or more instructions, followed by the file name to parse, one or more files that is generally how you'd use sed to parse data. Now again, it's a stream editor, so it takes, let's say, an input of text one line at a time and allows you to either extract or manipulate that text. So you can, for example, extract the first 3 characters, the middle 3, or characters after a certain series of texts, or match based on case. You name it. Anything you can think of, sed allows you to do it from the command line, no differently than you would do using an editor such as Nano or VI, so on and so forth. It also allows, like awk, scripting via the -f option, the ability, that is, to program a series of edits in a script file. So you can call a script file from sed. So like awk supports scripting using the -f option, which means you can program all of the changes that are to be made in a script file. And those changes get made one after another. So if you've got 10 changes, change 1 is applied, then change 2 through 10 on the first line before sed moves on to the next line. You can use sed to print basic information, like specific lines of a file. Let's jump right into the usage. Here's sed with an option, the -n option. The -n option suppresses lines that don't match, which means you'll need to use the the P option, that is, to print lines that do match. Supposing we want to print the first line from a text file, simply indicate the number 1 followed by the P option. It's a rule that whenever you use N to suppress lines that don't match, you need to use P to print lines that do match. We'll do so against our grep1.txt file. It's a useful file for multiple reasons. So it prints the first line of the file. And we should also note that just like awk, as well as other programs, sed supports input via a variety of methods. So supports input via stdin, or standard in, which means you can execute sed with no specification to a file, and it'll wait for you. It'll wait for input on standard in. It will also accept input via pipe as well as via file. So 3 basic ways you can get information into sed for processing. With that said, let's print the first line of grep1.txt. You certainly could use the head command to function like sed by indicating head-n, the number 1, followed by the file name. It would perform exactly the same as this sed command that we're about to execute. Now, of course, we're in the wrong directory, so let's navigate back to Linux CBT's home directory to the test RH5. In fact, we'll just open a new shell altogether and then navigate into test RH5 and then Control-Shift-V, where you see it's printed the first line. Now you don't have to take my word for it. Cat grep1.txt, and you'll see that the first line is indeed Linux. So supposing you wanted to print line number 2 from the file, well, then change 1p to 2p and it prints a second line, just like that. Now what if you wanted to print a range of lines? Let's say the lines 1 through 5. Well, indicate 1 comma 5 and there's your range. It prints the first 5 lines, which we can corroborate with the information above. So it's quite easy to return information from a file. Sed 1 comma 5p grep1.text prints the first 5 lines of the file, which again is just like using the head command. If you were to indicate head, the number of lines 1, against grep1.text, you'll see it returns the same thing. If you indicate, for example, the first 5 lines, it's the equivalent of indicating 1 comma 5p to sed. So head might be a better utility for you to do such simple things, but head will not help you, or sed will, when it comes to extracting data from a file. Now let's continue with some more general usage. You may also use sed to print, let's say, the last line, just like using tail with the -n and 1 option. Sed with $, which is the anchor tag used in the egrep world, followed by grep1.text, prints the last line of the file. Let's give this a try from the shell. Again, $, is an anchor to mean the last, and in the case of sed, it means the last line of the file. You can cat the contents of grep1.text just to be sure that the number 6 is the last line, and it does indeed work. Now you may be wondering, what if the file contains a space as the last line? Let's go ahead and make that a reality by pressing enter, and now we've got a space as the last line. Let's see what happens when we execute that sed. Notice it prints the last non-numeric. Let's create yet another line. Let's try that again. And notice it now prints a space. Before we didn't have a full or truly distinct line. Now we have a new line, a distinct line, and it prints it. It is the last line. It's occupying a line in the file. And sed finds it and prints it. So it prints non-printing characters such as spaces, as well as printable characters such as numbers, letters, punctuation marks, and so on. Now sed supports a whole other range of features, such as addresses, which we can use in conjunction with regular expressions to include or exclude lines. We've shown you how to do a range. We could print, let's say, lines 1 through, or all lines, let's say, except 1 through 3, which would be an address range. Let's try that as an example. That's a way of excluding certain lines, like an inverse execution in grep. So sed with the N option to print, and you may also turn on the optional E option, but it's not necessary. It's usually only required when you have multiple commands, multiple actions that you'd like to execute in between the single quotes. So in this case, we're going to sed N, print all but lines 1 through 3. 1 comma 3 exclamation is a way of negating this match. So here's a match. 1 comma 3 meaning the range 1 through 3. But we're going to negate the match and indicate to sed that it should not print those lines, which means lines 4 through whatever will be printed. And if we look at grep1.text, we'll see that line 3 is this training line, which means lines 4 through 16 will print, beginning with the uppercase word grep. And there you see it's begun with grep and terminated with the space at the end of the file. So prints all but lines 1 through 3. This is a way to negate what gets printed, or negates the match that we intended to perform. Now just like awk, sed supports matching of characters. So if you wanted to search for, let's say, lines that contain Linux, you could sed N and in between use the // terminated by P, and then search for, let's say, Linux against grep1.text. This will print lines with Linux. Let's give this a try. And so far we're just doing some basic things with sed. We've yet to touch on the real strength of sed. Let's just terminate this with a single quote that's imperative, and that is its search and replace capability. So there you see it. Search for it. Let's search for lines with numerics, for example, 0 through 9 as a character class that we'd like to search for. And we'll just go ahead and indicate that 0 through 9. And here we've omitted our regex search pattern, and there you see it prints lines which contain numerical values, even those that contain alphas, because they contain. And you could also restrict the search to only 0 through 9 using indexes. For example, let's say we want to find lines that begin with 0 through 9. That's certainly a possibility. You can include the circumflex, and then it returns only lines with 0 through 9. And if you want lines that only terminate with numbers, then also include the $ as an anchor. The same anchors are supported. This now returns lines only with numerical values starting and ending the lines. You can also search for full character strings or inversions to character strings by indicating the circumflex or indexing with the circumflex or using an exclamation, so on and so forth. Now, moving on to some of the strengths of sed, such as the ability to manipulate text. For example, what if you wanted to delete blank lines? Sed, with the execution option optional, followed by a search for blank lines. And the way you search for blank lines using POSIX regex is to indicate the circumflex or the caret symbol immediately followed by, with no spaces in between, the $ symbol followed by the action delete. So as you may have seen so far, the way you indicate an action to sed is to follow up your match with the action. Similar to awk. With awk we specify an optional match followed by the action. Same thing in sed. Here's the match. Look for blank lines followed by a delete. If you find the blank lines, delete the line. Now we want to search in the grep1.txt file, and the output will give us everything that's in grep1.txt minus the blank line. That's clear screen, and we're missing a single quote after the D, so we'll just include it. And now notice it's printed everything minus the trailing blank line. So it's a way to clean up or manipulate your data. So let's just go ahead and indicate what this line does. And we should also close this out with a single quote. And just indicate this deletes blank lines from the document. And you can optionally use standard out to create a new file based on that. Now let's sprinkle some spaces throughout this document so that we know we definitely have spaces that sed should catch. Back to the shell, and there you see sed has cleaned up the output, and if you want to create a new file, then just run a variation on this. Option number 8, throw in output redirection, which becomes so important. And let's create grep1, or we'll call this now sed1.txt. Deletes blank lines from the document grep1.txt and creates sed1.txt, which is identical minus the blank spaces. So this is a great way to clean up documents that contain spaces, or blank lines that is, sprinkled throughout the document. Let's give this a try. We'll echo the exit status. It's always good regardless of the command you've executed. And now you see the status is 0, which means we should have a sed1.txt file. There it is. It's 84 bytes. If we compare it to grep1.txt, which is 88 bytes, it seems to stand to reason, as we had about 4 spaces. So now let's cat the contents of sed1.txt, and as you can see, it contains no spaces. Now, of course, we've searched for and deleted blank lines, but you could search for and delete anything. For example, if you wanted to get rid of lines containing Linux, no problem. Instead of searching for spaces, instead of dumping this to the screen, instead of searching for blank lines, that is, search for Linux. This will get rid of lines containing Linux. You can also include multiple instructions by separating those instructions using a comma. So you could search for Linux, comma, space, or blank line, and it will remove both of those. Or you could send the output of this back into the input of a new sed instance to remove spaces. So this has removed Linux from anywhere that it's found it. And let's go ahead and turn on that case-insensitive search, and it's not taking it because of the way we indicated it. And it's also because we've instructed it to delete the item, which makes perfect sense. So the rectification for this is to pipe it into a new instance of sed. So we'll pipe it right back to sed, and then now search for blank lines using circumflex and the $, and instruct it to delete those lines, and now you'll see that it cleans up the output, removing Linux as well as the blank lines, cleaning up our output for usage. So again, that's a way to delete lines that are of interest, and there are ways you can alter this so that it removes anything that you're looking for, so long as you indicate the appropriate meta characters or string literals. You may also delete lines beginning at, let's say, specific lines by specifying a range. That's totally possible using sed. Now the real power of sed is search and replace. And the way you implement search and replace is to indicate the S option. So sed, and we would be searching for a string. Let's say in this file Linux we want to replace it with Unix. So you search for something, then you replace it. And you can print it if you have the non-matching turned on. So you turn on the N option, then print whatever has taken effect, and you'll see momentarily. So this will search for something and replace it with something. Let's just cat the contents of sed1.txt to be sure that it has what we have in mind, Linux, and it does. Then set up our command, which is based on what we have above. And that is going to be to search for the keyword Linux, and you could literally search for blank lines and intersperse something or replace it or substitute it with something else. And we'll change this to Unix. But we won't save the changes to a text file. We'll dump it to the screen just to be sure that it's working as expected. And there you see it's changed the lone line to Unix. Now if we didn't want to suppress the output, we could drop the N option, drop the P option, then all lines would be returned, including the line that has been changed. Notice the first line is now Unix as opposed to Linux. This is the real power of a utility such as sed, the ability to search for different types of text and make changes. You can make changes, for example, wherever a G is located in the document, change it to a P. And wherever there's a G, like with training, it now becomes a P. How about wherever you find the number 3, or since we have 2, we have multiple instances of each, so we'll make 3, 4. Now it changes each instance of 3 to 4. Again, we haven't updated the source document. We've simply manipulated the standard out, what's sent to the screen, so it has no bearing on the source file. And by the way, there's a way to update the source file, consequently backing up your original file. Sed, with the help option, returns the ability to back up your original file. Use the -i option to make an in-place edit, specified by a suffix such as back, like BAK, and the source file, the original file, will be backed up with a .BAK suffix, and the original name will be used to create a new file which contains a new data stream. So like with the sed1.txt, if we were to include, for example, -i.bak, now we see no output on the screen. However, if we lsltr, we have the original sed1.txt, which now contains the new data, and the original sed1.txt, which contains the original data set, which had 3s instead of 4s for our substituting. So let's just indicate that as well. Sed with the -i option .back, followed by any amount of options that we want. In our case, we executed it with simply, let's go through our history, sed with the E option, so we didn't suppress the output. So E option, we searched for something that was the number 3, and we replaced it with 4. And let's just check our output here. And then we did so against sed1.txt. This backs up the original file and creates a new sed1.txt with the modifications indicated in the command or in the action section. And we did mention that sed supports scripting. Sed with the -F option followed by the script file will cause sed to open that script file and process one line at a time the items that it finds in the file. Now let's just make a note. Generally, to create new files, use output redirection instead of allowing sed to write to stdout. Again, with utilities like sed, awk, grep, the output tends to go to standard out. In fact, most Linux and Unix programs will send their output to standard out, which is a screen, which tends to be the TTY that you're connected to, whatever that happens to be at any point in time. In this case, it's sudo terminal number 3. In this case here, for this shell, it's sudo terminal number 2. If you're at the console, it may be dev console. If you're on a serial line, it may be something else, SSH line, sudo terminal. The bottom line is, you need to realize that most Linux programs will send its output or their output to the screen, and you need to find a way to work around that. And the generally accepted way of doing so is using output redirection. Some programs like sed have this built-in -I option, which allows you to bypass standard out while backing up the source file. The idea is you should use it so you don't clobber the source file. Otherwise, sed would end up clobbering it. Now, this is the GNU version of sed, which has this -I option. If you take this to, let's say, a non-GNU version of sed, you may not find this functionality built in. So just keep that in mind. But again, just to recap, sed is a stream editor. It reads, just like awk does, files one line at a time, and it operates on those lines using the instructions that you've supplied on the command line or via script. If you've specified one or more commands on the command line or via script, those one or more commands will be applied to each and every line that sed reads. We should just note that as well. Sed applies each instruction to each line. So if you've got 10 instructions, whether supplied via script or via the command line, sed will take its time applying those instructions to each and every line, which may or may not have the desired effect. So you need to keep track of that, be cognizant of that. For example, if you've changed Linux to Unix, but then your subsequent change is to do something else, like make Linux something else, then the second change will be lost because Linux would have been changed to Unix. So you have to keep track of where sed is at all times by writing smart scripts. And it's really not hard. It's very straightforward to do. But you use sed to make textual changes, generally to clean up empty lines, to search and replace. This is where the power is. To search through documents looking for key characters, and it gets way more complex than what we've shown you. You can use a wide variety of regular expression characters to search for very specific sets of text and have sed march through them, make the changes, and transform your data. So that's what you'll use sed for. Now we're going to move on to some other things that you need to know, but these are some of the basics. We've thus far covered grep, awk, as well as sed. Those are three key Unix and Linux utilities, regardless of distribution.